Hi, Algebra 2. We are going to go ahead and add and subtract rational expressions today instead of multiplying and dividing. So we talked about factoring and then canceling or simplifying common factors when we were multiplying and dividing on day 7.1. So now we're going to be looking at adding and subtracting. And in order to add and subtract, the one difference is that we know we're going to have a common denominator. So a little change from day 7.1, we need a common denominator. And in order to have a common denominator, or in order to find a common denominator, our denominator is going to be the LCD, right? Your least common denominator. When you guys were in elementary school, you guys found least common multiples, so it's kind of similar, but an LCD is the least common denominator. So what we're going to look at is, let's pretend like numbers 1 through 6 right now are just the denominator of an addition or subtraction problem. If this is one denominator and this is the other denominator, again, our first step is going to be to write these as factors. So x plus 3 is already factored. 2x plus 6, I can take the 2 out and then write it as multiplied by x plus 3. So what the two polynomials basically have in common is they have the x plus 3 part in common, and then they need the additional 2 because this first one doesn't have a 2. So this second one has a 2, the first one doesn't. So in order to include everything that both of them might need, my least common denominator, I need to take the 2 and the x plus 3. So down here, for number 1, my least common denominator is going to be the 2 and the x plus 3. Let's look at number 2. Number 2, I cannot factor 2x minus 1. There's just nothing for me to factor out. 3x plus 4, I also cannot factor anything. So that's actually as simple as those two get. So in order for me to take my least common denominator, I am going to actually have to include both of them because there's no repeat anywhere. So I'm going to need the 2x minus 1, and I'll need the 3x plus 4. For number 3, x squared minus 4 factors into x plus 2 and x minus 2. And then I have x plus 2 in my other denominator. So they actually share an x plus 2. So for my least common denominator, I can take the x plus 2 because they both have it. But then we also need the x minus 2. One of them has it, one of them doesn't. And I need to make sure I'm including enough so that we have at least a common denominator, right? So we're going to need that x minus 2 as well. So I'm going to go ahead, and if I include the x plus 2 and the x minus 2, I have at least what shows up in both. For number 4, I can factor. So x squared plus 7x plus 12 will factor in x plus 4 and x plus 3. And then I have this x plus 4 as my other denominator, because remember, I'm pretending all of these are denominators at the moment. So for my least common denominator, can you guys guess what it'll be? We're going to need at least the x plus 4, right? Because that shows up in both. And then I also need to make sure I have the x plus 3 because we need to make sure we have enough to make both denominators. All right, number 5. I have x squared plus 5. Because that's addition, I cannot do anything to that one. I'll have to leave it as it is. And this is x minus 25. Man, I wish that was x squared minus 25, but it's not. So I can't factor that one either. That means that I will have to take both of them. So for my least common denominator, I will have to take x squared plus 5 and x minus 25. All right, last but not least, let's look at number 6. X cubed, remember that is really 3 x's. 1, 2, 3. 6x squared is really 6x and x. In order for me to have enough to make both denominators, I'll put my number 6 over here. My least common denominator, I'll have to at least have 3 x's. All right, so I at least need to have the x cubed. because I need 3 of them to make the first denominator, and I need 2 of them to make the second. So here's 3, here's 2. So I at least need to have 3. And then I also need to have that 6 because I don't have any other numbers there, right? I need to be able to make both denominators out of my LCD. All right, so that was a little background on how we're going to get our common denominator, because that's going to be important later on. Let's look at, just for example, if we already had a common denominator. So you guys know, think back to elementary school, when you guys are adding fractions, if we are adding or subtracting, we need to have a common denominator. So if I'm adding or subtracting fractions, I need to make sure I have a common denominator. If we already have a common denominator, then it's super simple, right? If both of my denominators are the same, so same denominator, if that's the case, then I just keep my denominator of 2, and I can just add my numerator together. So 5 halves plus 3 halves, 5, 6, 7, 8, gives me 8 halves, which reduces down to 4. Same thing with number 2. I have the same denominator, so I can keep my 3 as the denominator, and my numerator is 7 minus, and then it's 9x minus 1. Well, the reason why I had to put parentheses was because that minus sign has to distribute to everything behind the minus sign. So that means it's going to be negative 9x minus 1, which is really going to make negative 9x and then a positive 1 if you distribute that negative. So what we're really looking at here is 7 minus 9x plus 1 over 3, which is really going to be 8 minus 9x divided by 3. Okay? Simplifying the numerator, my denominator is 3 because it was the same from the beginning. Number 3, we're adding a little bit. We're not just working with a number as our denominator. Now we have an expression as the denominator. We'll let the bell ring. So we have the same denominator still, which means I keep, here I'll draw a little line there, I'm going to keep my same denominator. So anytime that you already have a common denominator, great, just keep it. And then 9 is going to add to x squared plus 1. Remember, it doesn't really matter here whether I have parentheses or not because we're adding, so we're just going to combine all of our like terms. So for this one, we will get 10 plus x squared over x plus 5. And then last but not least, number 4, we have a common denominator still. So we're going to keep our common denominator of 9, and then I'll add my numerator. So x plus x minus 3. Combine my like terms, so x plus x is 2x minus 3 over 9. Okay? So if I have a common denominator, this works out super well because I can just keep my common denominator and add my numerator, subtract my numerators, all right? So now let's get into the fun part. If I do not have a common denominator, what winds up happening? Without a common denominator is when I have to think about what my LCD, my least common denominator, would be. The easiest way to think about this is if you guys take a look at what you're already given as your denominator, see if it's already simplified, just like we were doing earlier with our LCD page. We were looking to see if these were already simplified. If they weren't, we factored them, but if they were, then we kept them the same, right? So right now these are simplified, and what I'm going to need is if I have a y minus 1 and a 1 minus y, I actually have to take both of them as my LCD, my least common denominator. So that means I'm going to need to multiply my left fraction by the one that it's missing. So it doesn't have a 1 minus y, so I need to use the 1 minus y. If I multiply by the denominator, though, I also have to multiply by the numerator. The other fraction already has a 1 minus y. It needs a y minus 1. And again, if you multiply by the denominator, you also need to multiply by the numerator. Basically, what you guys are doing here is just multiplying both of the fractions by 1, because y minus y divided by y minus y is 1. 1 minus y divided by 1 minus y is also 1. So that's what we're doing here. Our next step would be to simplify. So I now have, let's distribute this y. So I now have y minus y squared plus, let's distribute this, 2y minus 1. And we have the same denominator now, 1 minus y, oops, and y minus 1. Okay? So if I can simplify, I will continue to simplify, which I can. And I will take, let's see, y plus 2y gives me 3y. So now I have negative y squared plus 3y minus 1 divided by 1 minus y and y minus 1. Okay? I am going to leave number 12 for you to try. Let's go ahead and look at number 13 for a minute. In order to look at 13, I'm going to have to erase this one real quick. There we go. So now I'm looking at 13, and I notice that my denominators are not in factored form, so I'm going to take a second to factor these first. Okay, my first denominator is going to be x plus 3 and x plus 2. 2 and 3 multiply to make 6, and they add to make 5. And then on my other side, I'm going to have x plus 1 and x plus 2. 1 and 2 multiply to make 2 and add to make 3. What you guys will notice is that both denominators already have an x plus 2, so that part is already common. The part that's different is the x plus 3 and the x plus 1. My left-hand fraction needs to have an x plus 1 in order for it to be common, which means I need to multiply both numerator and denominator by x plus 1. The right fraction already has x plus 1. It needs an x plus 3. So I'm going to multiply both my numerator and my denominator by x plus 3. That now makes my common denominator x plus 1, x plus 3, and x plus 2. So all three of those are now part of my common denominator because they show up in both. So to get my numerator, I'm going to have to distribute. So I get an x squared plus x. And then you guys will notice that this problem is subtraction. If I subtract, I want to make sure that that subtraction distributes to everything after it. So I'm going to go ahead and put parentheses up to make sure that I distribute the subtraction. So now 2x times 3 is going to be 2x, and then 2 times 3 is going to be 6. So now I've rewritten and I've distributed, so my last job is going to be to simplify. So let's see, I have an x squared plus x minus 2x, if I distribute, and minus 6. And then my denominator is still the same. Okay? And again, I'll just double check if I can simplify any further. I have two like terms here. So I have x squared minus x minus 6. My denominator is x plus 1, x plus 3, and x plus 2. Now the fun part about these is that now we've learned how to practice factoring, so we can actually check if we can continue to factor the numerator to see if we can simplify any further. So if you guys look at the numerator here, I can actually factor this numerator, x and then, let's see, 3 times 2. And then in order to add them up to make a negative 1, I can make the 3 negative and the 2 positive. Well, that helps me a little bit because I can cancel out the x plus 2 now. So that does make my problem a little bit easier to work with. So now my final answer is just going to be the x minus 3 over x plus 1 and x plus 3. Okay? All right, guys, I'm going to leave these two problems for you guys to try, and we will be doing many more like this next class, and you can ask me to double check your work as well. Have a good night.